Hello, Pre-Calc students. This is Mr. Hazelhorst, and I want to take you through today's lesson on rational functions. What we're going to focus on today are some different characteristics of rational functions and also the ability of what we look at when we graph a rational function. All right? So you should have a note sheet in front of you that has all the slides that you're going to see on today's video. So you should be able to follow right along. Hopefully this will save you a lot of writing and you can just focus on the work that you're seeing on the screen and work through the example problems with me. All right, so if you look at the second slide, what I first want to look at here are all of the steps for analyzing the graphs of a rational function. And I'm just going to talk through these steps real quick. This will make more sense as we look at other slides and as we look at some example problems. But all the problems that I do as an example in class, I want you to relate back to these 7 steps. This is what the process that I'm going to look through. All right. So step number 1 is we always want to simplify the function if possible. And what we're going to be looking for in that step is holes. Now, we'll talk about what holes are in a little later on in this lesson, but that's what we want to focus on to begin with. All right. So simplify. Then we're going to plot the y-intercept. All right. There won't always be a y-intercept. Remember, the y-intercept is going to come from setting x equal to 0 and seeing what comes out of the function. All right. Step 3, we want to find the zeros of the numerator. That's what n of x is representing. Those are going to represent our x-intercepts. Step 4, we want to find the zeros of the denominator. All right. Those will serve as our vertical asymptotes. Then we want to find and sketch any horizontal and slant asymptotes, and we'll talk more about this here in a couple slides. And then finally, we want to plot some points and sketch using a smooth curve. All right. So when I work an example problem, I want you to go back to those 7 steps. And that's the process that I'm working through as I do that. All right. So let's talk a little bit about the basics of a rational function here. Hopefully what you remember from Algebra 2, rational functions are anything that can be written in the form of a fraction. We know that the domain is going to exclude any values that make the denominator 0. And that's where our asymptotes come into play. And that was step number 4. Again, we find the zeros of the denominator. Those will be undefined points. Those take on asymptotes. That'll be a big part of our graph. All right? So let's get into some specific characteristics of rational functions. And then we'll get to an example to start. All right, so here are characteristics of the graphs of rational functions. First off, we're going to have asymptotes. Okay? Vertical asymptotes are going to occur at the zeros of the denominator. Again, we know from working with rational functions in the past that we can't have 0 in the denominator. That caused the function to be undefined, and those asymptotes are representing the undefined portion of the graph. All right? We can also have horizontal asymptotes, and horizontal asymptotes can occur 3 different ways. All right? So we want to make note of this as we look through. So if we compare the degrees of the numerator, right, again, top function, to the denominator, the bottom, right, here's what we're looking at, right? So if the degree of the numerator is smaller than the degree of the denominator, all right, y equals 0 will always be our horizontal asymptote, okay? So smaller degree in the numerator, y equals 0 is that horizontal asymptote. If the degrees are equal to each other, then what we look at is a ratio of the leading coefficients. And we'll see an example of this problem, or of this type of asymptote, on our second example problem. Okay? And then finally, if the degree of the numerator is larger than the degree of the denominator, then there aren't going to be any horizontal asymptotes, but there may be a slant asymptote. And we'll talk about slant asymptotes before we get to the last example. Our last example will have a type of slant asymptote. So we're going to look at 3 examples. The first example will be of the numerator less than the denominator in terms of degree. The second example, they'll be equal. And third, we'll look at what a slant asymptote looks like and how we graph that. Okay? So let's get to our first example. And you can see this right on your notes. So this is your opportunity to kind of write some things down, follow along the work that I'm going to do. And again, we're going to work through those 7 steps that you have on that top part of the notes that have been handed out to you. Okay? So we're going to find all the asymptotes of this. We're going to find zeros and so on. And we're also going to graph this function. All right? So step number one is to simplify this function if at all possible. Now, I can't really simplify anything down, but what I can do is I can factor this further. So I'm going to look at this function as 2x divided by x plus 1 and x minus 1. I can factor that denominator as a difference of squares. And that's going to be important as we work through the graph of this function. So step number one, all right, we simplify. In this case, we were able to factor. Nothing's going to cancel out. We're not going to have any holes in this problem. We'll talk about those in the next example, okay? Step number two, if we look up above, is to plot the y-intercept if there is one, all right? So we're going to plug 0 into this function for x. So if I plug 0 in at x, all right, I get 0 in the numerator, and I get a -1 in the denominator. So that means that this 0, right, the y-intercept, will occur at 0. So I'm going to plot that point right on the origin. Okay, that's my y-intercept. Step number 3, all right, we want to find the zeros of the numerator. All right, what value makes the numerator 0? And that's going to be the x-intercepts of this graph. Well, if I look at my numerator, right, my numerator is 0 at 0. Now, we already had that plot pointed because that was also our y-intercept. So here the origin is both our x and y-intercept in this example. Okay. Step number 4 then is we need to find the zeros of the denominator. All right, what values will make this denominator 0? So this denominator will be 0 when x is a -1 and when x is a +1. And we're going to graph these as vertical asymptotes. Okay? So I'm just going to have a dotted line right at a -1 and right at a +1 serving as those, excuse me, vertical asymptotes. All right? Now, step number 5, we need to find and sketch any horizontal asymptotes that we have. Right now, before we do that, I want you to recognize this graph is going to be divided into 3 different branches. Right? We're going to have a branch on the left side of -1. That's our first branch. We're going to have a branch in between the 2 asymptotes. And then we'll also have a branch on the right side of a +1. All right? So there are 3 parts to that graph based on those asymptotes dividing that graph up. Okay? So if we take a look at our horizontal asymptotes, again, to determine our horizontal asymptotes, we need to compare the degrees of the numerator and the denominator. All right? So when I look in this graph, my numerator is a first-degree function. My denominator is a second-degree function. So that means my larger degree is in the denominator. And if we look back on our previous slide, what that means is that y equals 0 serves as our horizontal asymptote. So I'm going to pass through this function through the left side. Now in the middle, right, we know that 0 is not going to serve as an asymptote there because of the intercepts, the x and y intercepts. So I'm going to skip over that part, and then it'll serve as an asymptote on the right side as well. Okay? So if we were listing out our asymptotes, let's go back and do that in this problem. Right? Our vertical asymptotes are occurring where x equals a -1 and where x equals a +1. And we should always represent vertical asymptotes as an x equals line. Okay? Our horizontal asymptotes in this problem is that y equals 0. And again, that's because the degree of the denominator is larger than the degree of the numerator. All right, so now we've got all that information graphed. We've got our asymptotes, our intercepts. Now what we're ready to do is to plot some points and help determine what this graph is actually going to look like. So what I'm going to do there is just simply create a table of values. And what I want to do is I want to graph a couple of points on each side of the asymptote. Okay? So let's start out with our asymptote where x is equal to a -1. So a couple of points on the other side of that would be x equals a -2 and x equals a -3. So let's just evaluate this function using those 2 values for x, and then we'll have some points that we can plot. Okay? So if I plug a -2 in for this graph, my numerator would be a -4, and this would all be over 4 minus 1. So we'd end up with a negative 4/3. All right, that's my output there. So if I graph that, if I go over to a negative 2, I'm down a little bit more. It's about 1 1/3. So here's my point right here. Okay. Now, if I evaluate a negative 3, we end up with a negative 6 divided by 9 minus 1. So we end up with a negative 6/8, which I could reduce down to a negative 3/4. So if I plot that point, we're at a negative 3/4 at negative 3. And now I have a pretty good idea of what this left branch is looking like. My asymptotes serve as some guides to help me sketch that graph. So I'm going to pass through those points. And that's what our left branch would look like in that graph. Again, we're not going to cross or touch our asymptotes, but we're going to plot those points and sketch that left branch. So now let's plot some points in between a negative 1 and a positive 1. Now, the bad news is, to get a good idea of this graph, we're going to have to utilize some fractions. All right. So if I plug in a negative 1/2, okay, that'd be in between 0 and the asymptote of negative 1. So a negative 1/2, that's going to give us a negative 1 in the numerator, and in the denominator, we're going to end up with 1/4 minus 1. So we end up with a negative 1 over a negative 3/4. We divide by the reciprocal. We're going to get a positive 4/3. So that's my graph there. At a negative 1/2, I'm at about 1 1/3. Right, plot a point about right there. So then we're going to look at a positive 1/2. So this would give me a positive 1 over 1/4 minus 1, which would end up being a negative 4/3. So at a negative or a positive 1/2, I'm at 1 1/3 on the negative side. Now that gives me a pretty good idea of what this graph is going to look like. So we can see based on these points, I'm going to follow along downward on this left asymptote, pass through my 3 points, and then follow my asymptote on the right. And that's going to give me what that middle branch of this rational function would look like. All right, the last part that we need to look at then is the right side of the graph. So again, we want to plot some points there. So if I plug in 2, all right, well, I kind of done that work up above. 2 is going to give me a positive 4/3, and 3 is going to give me a positive 3/4. So if I plot those points, 2 is at 1 1/3, 3 is at 3/4. We're going to follow along those asymptotes as a guide, and there's the graph of our rational function. And that's what I want you guys to be able to do today. Can we take that rational function? Can we analyze it for our y-intercepts, our x-intercepts, our horizontal and vertical asymptotes, and can we sketch that graph? Okay? So there's example number 1. Now let's take a look at another special characteristic that we want you to be aware of, and then we'll look at an example of that. So let's talk about holes here real quick. All right? Holes occur when the numerator and the denominator have common factors that can be simplified. Right? That's going to create an undefined portion to our graph, or a hole. So we'll look at an example here that will help us to see that. All right. So here's our function to start. So again, we're going to follow those same 7 steps. I'm going to move through this a little bit quicker, but again, remember this video is posted online if you need to access it at all and watch it again. All right. So the first thing I'm going to do here is simplify this graph. And I can factor this one, so let's factor this out here, numerator and denominator. This would factor into x plus 2 and x minus 1. Okay? Our denominator would factor into x plus 2 and x minus 3. Now, if I look here, I have common factors between my numerator and my denominator. So these x plus 2's would cancel out, and really all we're left with is the function x minus 1 and x minus 3. Now, because we canceled out these x minus 2's, what this means is I'm going to have a hole in my graph wherever x is equal to a negative 2. Okay? So we'll come back and we'll fill the hole in at the very end. But again, I want to recognize we've canceled out a common factor. That's what creates the hole. So at this point, I just need you to recognize that there is a hole. We'll show you how to put that onto your graph in the end. Really simple, okay? So let's go through our steps here again. So the first thing I want to find is my y-intercept. I'm going to plug in 0 for all my x's. If I plug in 0 for all of my x's, I'm going to end up with a -2 over a -6, which would reduce down to a positive 1/3. So I'm going to cross the y-axis here at a positive 1/3. My second step, as we go through those 7 steps for analyzing the graph of a rational function, or excuse me, I've done my second step. Our third step, we need to find the zeros of the numerator. Now we've simplified this function down, so the only vertical asymptote of this graph is going to occur at x equals a positive 1. Okay? So, made a mistake here. All right? Those are my zeros. That's going to be my x-intercept. Excuse me, I apologize for that mistake. So my x-intercept is going to occur where x equals a positive 1. So this is where I'm crossing the x-axis. So we got our y-intercept, our x-intercept. Right, now let's find our vertical asymptotes. All right, getting ahead of myself here. So my vertical asymptotes are going to occur where the denominator is 0. So the denominator will be 0 at x equals 3. So we're going to sketch in that vertical asymptote where x is 3. Now we want to analyze our horizontal asymptotes. So again, we want to compare the degrees. So notice that I have a first degree equation over a first degree equation. Our degrees are equal in both our numerator and our denominator. So this is our second example on the horizontal asymptotes slide. So when the degrees are equal, we're going to look at the leading coefficients. Now, both leading coefficients here would be 1. So our horizontal asymptote will occur at a ratio of those leading coefficients. So it'll just occur at 1 over 1, which is simply 1. So at y equals 1, I have a horizontal asymptote. Okay? And again, what I want to do now is I want to plot some points to just get an idea of what's happening on the left side of the asymptote and the right side of the asymptote. Now, the good news is the y-intercept and the x-intercept help us to get an idea of what this graph is going to look like. So I'm going to go along here, follow that asymptote, pass through my y-intercept, pass through my x-intercept, and follow that asymptote down. And I know that's what's happening on the left side of my asymptote. Now let's look at the right side of our asymptote. So again, if I create a table of values here, some values on the right side of a positive 3 would be 4 and 5. So let's plug those in. And I'm going to plug those in my simplified function. That's going to be a lot easier than working with the original. So if I plug 4 in up here, I get 4 minus 1, which is 3, divided by 4 minus 3, which is 1. Okay? So when I plot that point, when x is 4, y is 3. Now let's plot input 5 into our function. So 5 minus 1 is 4. 5 minus 3 is 2. 4 over 2 is 2. So at 5, my graph is right here. And again, I have enough points now to get an idea of what this graph is doing. Okay. Now we're not quite done with this graph because we need to go back to what we identified early on. And we said early on there was a hole where x is equal to a -2. So all I need to do there is I need to go back to where x is equal to a -2. Right? I'm just going to erase a little bit here. And I'm going to put a hole right at that point. And that's what my graph is going to look like. All right? Because the original function, right, if we plug a -2 in, all right, a -2 would make this function undefined. And that's why we need a hole there. Okay? Now, it got canceled out as we simplified the function, but it's still a part of the original function, and that's where that hole occurs at. All right? So the last type of example we need to go through is the idea of a a slant asymptote. Okay? Now, slant asymptotes occur when the degree of the numerator is exactly 1 more than the degree of the denominator. All right? And what we're going to do here is use either long or synthetic division, and we're going to simplify this down until we get a linear equation. And when we simplify this down to a linear equation through long division or synthetic division, that linear equation serves as our slant asymptote. So I'm going to show you an example of this through our last example problem. But again, we're going to follow the same 7 steps that we have through every problem at this point. So let's get to our third and final example problem. Now, again, the very first thing that I want to do is I want to simplify this down if at all possible. And again, I can do some factoring in this problem that's going to help me out. So if we factor this to start, my numerator would factor into x times x minus 1. My denominator is just simply x plus 1. All right, now we can't cancel anything out, so we're not going to have any holes in this graph. We don't need to worry about that, but we will plot all those same points that we have up to this point. So let's start out by plotting the y-intercept, which again is going to occur whenever we plug in 0 for x. So if I plug 0 in for x, I'm going to end up with 0 over 1. So again, the origin is going to serve as a y-intercept. So we've got that point plotted at the origin. Then we need to look at the zeros of the numerator, which will tell us our x-intercepts. So we can see we have an x-intercept at 0, which we already have, the y-intercept as well. And we're also going to have an x-intercept at a positive 1. So I've got those 2 points plotted. Okay? Step number 4, we need to look at the vertical asymptotes. What makes the denominator 0? When I look at this function's denominator is 0 at a negative 1. So that's my vertical asymptote at x equals a negative 1. So we have that graphed. Again, that's the 0 of the denominator. Now we need to move on to either the horizontal or slant asymptotes. So again, we wanted to compare the degrees of the numerator and the denominator. So my numerator here is a second degree function. My denominator is a first degree function. This is where the slant asymptote comes into play, because the degree of my numerator is exactly 1 more than the degree of my denominator. So I'm not going to have a horizontal asymptote here. What we're going to have is a slant. And this is how we find the slant asymptote. We're actually going to do the division. Okay? So I'm going to take x squared minus x, and I'm actually going to divide it by x plus 1. Now, this problem we could do with synthetic division, but I know you have lots of practice with synthetic division. So I want to do a long division one, just to, again, see that process. So we take x plus 1, we're going to divide it by, x squared minus x divided by x plus 1. All right, so let's work through the long division. So again, what do I need to multiply x by to get x squared? Well, I need to multiply it by an x. So now I multiply that through the 2 terms of my divisor. So we get x squared plus x. We're going to subtract these then. So the x squareds are going to cancel, and I'm left with a negative 2x. And again, we go through the same process. So what do I need to multiply my leading term and my divisor by to get a negative 2x? Well, that's a negative 2. Now at this point, we can actually stop. We're not going to complete the whole division to get a remainder. We don't care what the remainder is. What we care is, all right, what's the quotient? What's left over from that division? And what's left over is a linear equation, x minus 2. And this x minus 2 is going to serve as our slant asymptote, right? So let's just graph that line as an asymptote. All right, so y-intercept of a negative 2. And then my slope is 1 over 1. So we'll go up 1 over 1. And you can see this line taking shape that, again, will serve as our slant asymptote. So just like before, we then want to plot some points on each side of our vertical asymptote to get an idea of what this graph looks like. Now, again, my y and x intercepts save me some work on the right side of this, because I can see if I follow my asymptote and pass through those 2 points, my right branch is going to look something like this. Now, I do need to do some work to find some points of my left branch. So again, we're going to create a table of values to do that. Right? I don't need to worry about anything on the right side, just the left side. So my vertical asymptote's at a -1, so let's plug in a -2 and a -3. All right? So if I plug in a -2 and a -3, so a -2 into the original function, -2 squared is a +4, minus 4, or minus a -2, excuse me. So 4 minus a -2 gives me a +6. And then a -2 plus 1 gives me a -1. So when my graph is at a -2, xy, the y value is at a -6. So -2, 1, 2, 3, 4, 5, 6. Now let's evaluate a -3. So if I plug in a -3, I get 9 minus a -3, which would give me a +12, all over -3 plus 1, which would be a -2. So again, I get a -6. So at a -3, I'm again at a -6. And again, this is now enough information. I can sketch this graph. I know I'm passing along my asymptote through those 2 points towards my other asymptote. And there's the left branch of this graph. Okay? So today's video, you've seen all the characteristics of a rational function you need to worry about. So we go back to our first slide. We saw an example of how we find horizontal asymptotes when the degree of the numerator is smaller than the degree of the denominator. We had a pretty simple graph there, 3 branches. Our second example, we saw holes. We saw a horizontal asymptote when the degrees are equal. And then in this last example, we saw our example of slant asymptotes. But again, I just want to stress to you, same 7 steps through all types of problems. And that's our information on rational functions. So here's your homework assignment today. I hope a good chunk of this made sense to you. If it didn't, remember this video is posted on our classroom website. You'll see a Pre-Calc videos link now on that website. But do the best you can on this homework assignment. We'll take time in class tomorrow to answer any questions that you may have. But I do want you to make note, we will have a quiz on Thursday that will cover all of our information about polynomials. Think about that worksheet from yesterday. The lesson from today, that information will all show up on your quiz Thursday. So best of luck on the assignment. Help each other out with the time that's left in class. And I'll be back to help you out with some questions tomorrow.